Hi, this is Becca, and this is Try Tutoring's lesson on writing and graphing lines. There are two forms we use quite often when we're writing and graphing lines. One of them is point-slope form. Point-slope form is y minus y1 equals m, the slope, times the quantity x minus x1. The y and the x that are listed first remain in this equation. We're not going to try and fill those in. That's what makes it the equation of the line. That's what makes it something we can use for future points. The other standard form, the other usual form that we see is slope-intercept form. Slope-intercept form is y equals mx plus b, where m is still our slope and b is the y-intercept, where this graph or this line crosses the y-axis. Again, y and x do not get filled in for these forms. So let's try an example together. On this first one, I want to write the point-slope form. So my first equation, the point-slope form. If I'm given the point 2, 3, and I know that the line has a slope of -3. If the line goes through 2, 3, this gives me x1 and y1 to fill in. So as I'm writing the equation in point-slope form, I'm going to replace the y1 with 3. I'm going to replace the slope with -3. And I'm going to replace the x1 with 2. If I had like something where I had a subtraction of a negative, happens pretty often. Maybe my y1 was -1. It is good to simplify two negatives into addition, but other than that, if I'm asked to write the point-slope form, I don't need to go any further. This is the point-slope form. I have filled in the point given, and I have filled in the slope. Now we may be asked to write the slope-intercept form. So on this next problem, I have the line that goes through the point 0, 4, and a slope of 1/2. Now I want to visualize for a second where 0, 4 is on the graph. 0, 4 means I have 0 as my x value. I didn't move left or right at all, and then I went up 4. If we go up 4, notice how that's actually on the y-axis. Because it's the point where it intersects the y-axis, this is b. This is my y-intercept. So if I'm given an ordered pair where it is 0 and then a number for y, that actually tells me the b. That tells me the y-intercept to fill in for my slope-intercept form. Since I already know the slope is 1/2, and I know that the y-intercept is 4, I can replace these values to write my equation as y equals 1/2 x plus 4. On this third one, I want to write the equation of the line in slope-intercept form, but I don't have a slope given to me. The points are 1, 3 and 3, 7. If you don't have a slope given, you'll have to find it using the slope formula. The slope formula is y2 minus y1 over x2 minus x1. So for these points, let's label x1, y1 and x2, y2. And then we fill them in for our slope. y2 is 7, y1 is 3, over x2 minus x1, so 3 minus 1. If I simplify this, 7 minus 3 is 4, 3 minus 1 is 2, and 4 divided by 2 reduces to 2. So in fact, I have a slope of 2. Now I still don't have everything that I need to fill this in and make it that slope-intercept form because I don't have the b value. So when I don't have the b value here, I actually find it's easiest to go through and use the point-slope form like I did on the first one. So I'm going to fill in y minus y1 slope x minus x1. So using that point given and using that slope I just found, y minus y1 equals slope times the quantity x minus x1. Rewriting this, I can pretty quickly get it into y equals form. Distribute the 2, we get 2x minus 2 on the right side. And then to get y by itself, which is what I want for that slope-intercept form, I would add 3 over to the right side so that I have 2x plus 1. And that'll make my final answer here. In addition to writing the equations of the line, we can also graph the equation of a line. So for this first one, y equals 3/2 x minus 4, it's in that slope-intercept form. I notice it's in the y equals mx plus b form. So I already know m, which is my slope, and I already know b, the y-intercept. Now to use those values and put them on this graph, I want to start at the y-intercept. So on this y-axis, I want to put a point on -4. Then I need to count my slope. Since the slope is 3/2, we count rise over run. So I will count up 3, up 1, 2, 3, and then to the right 2. And that's where I put my next point. I can even do that a couple times to make sure I have a really nice and straight line when I connect these together. So I can continue that slope up 3 to the right 2 because it was positive 3/2. Then to finish my graph, I just want to use a nice straight edge or a ruler and connect those points together, and that makes my line. Now the reverse steps are pretty similar. If I'm given a line and I want to write it in slope-intercept form, well then I need to find that slope and I need to find that intercept. I do think it's easiest to start by looking for the intercept. So I ask myself, where does this line intersect the y-axis? And I see that I have this point here at 3. So positive 3 is the b value. Now for the slope, I want to go from one point to the next. I want to look for some good intersections, and I notice that really this point and this point and this point, none of those come to the corner on this graph. None of them really come to that gridded mark. So it's not a good place for me to count. The next time I actually see a good point is at 4, 0 over here. So always count your slope, just like you would read a book from left to right. Counting here, to get from one point to the next, I have to count down 3 and to the right 4. Down 3 and to the right 4 makes a slope of -3/4. Once I have each value, I fill them into my equation. So in this case, my slope-intercept form is y equals -3/4x plus 3. And that's my final answer. So we looked at some examples of how to write, some examples on how to graph, and talking about that point slope form as well as that slope-intercept form. So hopefully it gives us some clarity here and some good examples to go through and use for future problems. So thanks for listening, and we'll talk to you soon.